Hello everyone. Today I'm going to explain my research topic is on about the estimating and initiation of the crack growth in the exciticity of the pipeline. So in this method, I'm going to find out my fracture toughness by using the CTOD and the resistance curve. And the main objective of doing this experiment is to reduce the material thickness and also uh, to find out the fracture toughness. And I want to make my research method by differentiating from the before material of X65 and X70. And before going to explain about my method, uh, you all to know about what is the CTOD test. So, what is CTOD test? The CTOD test is also known as a crack tip opening displacement test, which is used to measure the resistance of the material, and also by using the CTOD method, we'll know the where the propagation is going to start. And CTOD is used on the materials, majorly on the plastic, whichever the materials show the plastic deformation. Okay. And the coming to the slide, you have to know the what is importance and applications where the CTOD is applied. So coming to this, this can be applied in the multi-axial fracture characterizations and finding out the toughness of the plastic materials, and it is also used for the experimental measure to find out the driving force. And and this by seeing this graph, uh, from this we will explore some information, that is when the material is starting when the material is going to bend, it shows at this point the elastic deformation. And it is further going to show its fracture toughness. The various things are going to happen at this stage. The strain hardening and elastic propagation can be seen, and when the material is raised up to from this point to this point, it shows perfectly the plastic deformation. And the next slide, uh, here we are going to see what are the composition of the various steels. So before explaining about my XIT steel, which is I'm going to do on this, the comparing to these steels, it has low carbon composition. So you can see here it is 0.05 compared to X46 and X60, whereas here it is 0.25 and here it is 0.12. So because of this carbon content, it is very easy to weld the material. But in the X60 it is 0.12, which is little more than this. So because of this carbon composition, it is not reliable for the welding. So what are the various factors affecting the material toughness? So there are various things which are happening, which is showing major impact on the materials. So coming to the mechanical variables, external mechanical variables like temperature and loading rate and the environment, these are all the factors which are affecting the material. And coming to material variables, there we can see there is chemical composition, which I explained in the previous slide, whether because of carbon content, manganese, and all this chromium, all this, which affects which affects the material. So because of all these things, material has a major impact on this on the working of the on the working of this HNOs. And there are different modes of crack in the specimen. So while the material under testing, it goes different modes on the crack opening. So when from the mode 1, we can see it can be opened in the vertical direction, which the crack opening can be done in the vertical direction. in the in plane when the crack is in this form, it is said as in plane shear. And in the mode 3, it can be like plane shear, which can be like slightly get distracted from this position. And these are all the modes which I explained. Then the next go into this, there's a stress intensity factor. When the stress when it has more intensity in the material, when it shows a crack opening, here it forms a K zone, which is called as stress intensity factor, which has a major impact on the material. Going to design experiment, in my experiment which I'm going to do in this way. So in my design experiment, first I consider the three of the same materials of the X80, and I'll start to conduct my experiment by placing the double clip cage, which is mounted on the mouth crack of the material. So when the displacement after starting of the experiment, it show when the experiment gets started, it shows some displacement at the crack tip. So it opens the crack. From that we know the what displacement it made with this crack. Then after we'll do some fatigue test. So because of fatigue test, we'll know what is the toughness of the material. After giving some cycles, 20 cycles per hour, for example, and it is totally depending upon the strength, how much fatigue it can resist. The number of cycles can be increased depend upon the strength to know the strength of this material. And in my experiment, for going to few of the journals, I found that toughness is a major important, and the materials toughness is a major important, and material size and thickness of the material, crack propagation. Because of all these defaults in the previous materials, my X80 has shown some clear indications that it has some good strength on this. Coming to mathematical proof in my experiment from the previous material, we can save the 23% of the material, so that it would be very useful for the future to use this material, so that we are covering lots of cost. We are saving lots of the materials. By reducing the thickness in this from the X80, it shows good strength compared to previous materials. The toughness of the materials can be also saved in the X80 steel. And coming to the conclusion, it is very suitable for using this material. The crack resistance, the material can be saved, as well as it yields a good strength. Advantages and disadvantages. The major advantages of my material is that it can be used onshore and offshore of the pipelines, and it is reliable. Gives a reliable toughness, and we can cover lots of material. And disadvantages like investigations must be done in the material to know the corrosiveness, because it is not found in this experiment whether corrosiveness is it can withstand the corrosion. There should be need of information that X80 material can withstand with the toughness. So this is coming in the overall conclusion that this is very reliable. It is very reliable for using this, and it has a clear indication that it can yield a good toughness in the future, and majorly this is a material which can be used for the future considerations while in the laying of the pipelines of offshore and onshore, and this is what I'm going to explain. So thank you.